Hello class. Today we are going to be learning about quadratic functions. And a quadratic function looks like this. Y equals ax squared plus bx plus c. We've been working on these all through chapter 9. When you graph that function, it will look like a parabola. So let's take a look. Here is an example of what's called the parent graph. The original equation is y equals x squared. This is the graph for that. Notice that if we plug in a 0, 0 squared is 0, so 0, 0 are the coordinates for this point right here. That's called the vertex. Now what if we put in a 1? If we square 1, 1 squared is 1, so we get 1, 1. So you go over 1, up 1, and put a point. Same thing happens if you put a negative 1. Put negative 1 in here. Negative 1 times negative 1 is a positive 1. So you have points negative 1, up 1. So take a look at the table here, and you'll notice the points that you could use for what's called the parent graph. Y equals x squared is the parent graph for all other quadratics. Let's see what happens. Here's another picture of it. 0, 0 is the vertex. And if you draw a line right through the vertex through the middle of the parabola, that is actually called, let's write that down so you can write that into your picture. That is called an axis of symmetry. So this line that goes right through the middle is called an axis of symmetry. And this point that's at the bottom of the parabola, that is called the vertex. Oops. So make sure you draw that into your notes. All right. Now sometimes the parabolas will open up. The blue line here is the parent function, y equals x squared. The red parabola has a number bigger than 1 sitting in front of the x squared. The green parabola that's wider will have a fraction sitting in front of the x squared. Now, if the graph opens upside down, here's the blue one is the parent function. A negative sign would appear, which would allow it to flip over the x-axis. If it's red, the red line here, or parabola, it would be like a negative 4 squared, x squared, or negative 3 x squared. If you have the green, you'd have a fraction here for the a value, and negative, of course. So it'd be like negative 1/2 x squared would cause it to get wider, or we also call that as shrinking. All right, and then of course, if we want to move the actual vertex, we just put a plus c at the end. Let's take a look at what this looks like. Oops. And there. All right, y equals 3x squared. I would expect this graph to be more narrow, in other words, stretching. It will get closer to the y-axis, the parabola. And in order to graph it, I just simply write y equals x squared, and I start plugging in different x values. Usually we try to do a 0, 1, 2, and then negative 1, negative 2 going to the other side of it. And when you plug those in, you get these y values. For example, plug in a 1 here. 1 times 1 is 1, times a 3, you get a 3. Put a 2 in for x squared. 2 times 2 is 4, 4 times 3 is 12. So then you have this nice little table, and you could plot the points. This is what it would look like. And look, the parent graph is blue. That's the original. And then the image is the red parabola. And notice the 3 here caused it to get stretched out and more closer to the y-axis. All right. They still both have an axis of symmetry of x equals 0. All right, what happens if you get a negative 1/4? As you would expect, the negative flips it upside down, and the 1/4 will cause it to get wider. Now, if you want to actually plot some points, you just go ahead and write this equation, give yourself an x and y, and just start substituting in x's to figure out what your y values would be. Now, notice here they use 0, 2, and 4. And that's only because if you put in 2 for x squared, 2 times 2 is 4, which would allow you to cancel this 4 and the 4 that you would see right here. All right, so you get your points, and then you graph it. Now notice the red parabola is the negative 1/4 x squared. Here's the parent graph, the blue one. The negative caused it to flip over the x-axis, and the 1/4 caused it to shrink. It gets nice and wide. All right. A lot like our lines that we did and our exponentials that we did. All right, what if we have y equals x squared plus 5? And we want to compare this graph to the parent graph of y equals x squared. Right now I see a plus 5 at the end. That plus 5 would indicate that the vertex would move up 5 spaces. Now you can go ahead and give yourself an xy table, put in your 0, numbers to the right of 0, numbers to the left of 0, and get your y values. So for example, if you put 0 in here, 0 squared is 0, plus 5, you get a 5. Put a 1 in. 1 squared is 1, plus 5 equals 6, so you put a 6. So you can plot all your points, and look what happens. So here's my parent graph, the blue one, and look what happened. It went up to the 5 on the y-axis. So this little plus 5 written at the end causes it to go shifting up 5 spaces. A lot like our lines that we were working at before. We could take a look at the equation and know what's going to happen with the graph. All right. So here we have, compare the graph with the function of x squared. Y equals negative 4x squared. So the negative 4 caused it to turn upside down. The 4 causes it to get closer to the y-axis, so it gets really narrow. It stretches it. Now you could give yourself an xy table and be able to find all the coordinates on this parabola. All right. Oops. Oh my goodness, I just can't get that to work. Look at the 1/3. The 1/3 caused it to get narrow and compared to the parent. Oh, I'm sorry. My mistake. Wait. A 1/3 would cause it to shrink, so it would get wide. So this one on the outside here is the y equals 1/3 x squared, and this is your original parent graph. So it shrinks. All right, by a factor of 1/3. Oh, there you go. There's that factor, multiplication. And let's take a look at this one. X squared, so it's going to be exactly like the parent graph as far as the parabola is concerned, but this plus 2 at the end causes it to go up 2 spaces. All right, so that's a vertical translation of 2 units up. I think that's enough information for now. Let's just double check. I think we might have one more. Okay, what happens if we write this complicated equation? This negative 4 at the end, or minus 4, would indicate it drops 4. The 1/2 in front would cause it to shrink by a factor of 1/2. In other words, it gets wide. Now you could just plug in 0, 2, 4, and -2, -4 into here. How do you know what numbers to put in? You put in numbers that are convenient. Because if I do 2 squared, what's 2 times 2? 4. Half of 4 is 2. 2 minus 4 is -2. So I'm using even numbers when it has a half, so it can be convenient to get nice whole numbers, and then you can graph these on a table, or on a graph. Oops, let's go back. Here's the picture. Notice what happened. The 1/2 caused it to get wider. This -4 caused it to drop 4 spaces. All right, so that would mean it has a translation down 4 and a shrink by a factor of 1/2. That's enough for tonight. I'll see you in class.